Hello, welcome to another session on TLS SSL outbound decryption and SSL inbound inspection on the Palo Alto. Today we have this, you can see on the table, and it's absolutely, the coffee is next to me. It's absolutely Tuesday today and things are okay. So we have got encryption, decryption and certificate process for you today. Alright, what is the game and what is the themes and what's the objective? We're going to create outbound and inbound inspection certificates on a Palo Alto. We'll create certificate, we'll create decryption policy, we also create decryption profile, and we will attach the profile to a policy so that all the tick boxes are done. That way we can protect our data on on-prem and cloud as well. So what we have to tell the firewall is that only negotiate with TLS, right? 1.2. If anybody out there is having 1.3, then it's better. Otherwise, please do not accept anything below 1.2. What public key and private key we're going to tell the firewall? We're going to pick RSA, which basically uses asymmetric encryption algorithm, so that we basically have something, in place. Also, what sort of encryption we're gonna use? Absolutely AES. What about the hashing, privacy? Right, the hashing we're gonna use 256, or we call it SHA-2, and we're also gonna enable SHA-1. So if anybody out there is using, sorry, what did I say, SHA-1? No, SHA-3. So if anybody is out there using SHA-3, they're more than welcome. SHA-1, you know why? Because I get used to this for years, alright? So please let me take that back. Don't ever allow SHA-1 at all, okay? It's been broken and it's absolutely not basically healthy. So okay, so let's get going. Okay, so here's the lab. What we're trying to achieve is this. Now, anytime a PC from inside network is trying to access, let's say for example, take an example, Google PC, we simulating this as the destination network, alright? So this PC is gonna go out and wanna contact Google, and the firewall will negotiate with this TLS 1.2 or above, SHA-256 or above, encryption AES, no certificate or no connection. Absolutely. So what the firewall is going to do is going to say, hey boy, stop. All right, where you going? Oh, I'm trying to Google mate. Okay, so the firewall is going to intercept that traffic and it's going to talk to Google, hey, my client want to make a connection. Do you have 1.2, TLS 1.2? Yes, mate. Okay. Do you have SHA-256? Yes, mate. Do you have AES encryption? Yes, mate. Okay, fine, great. So Palo Alto is gonna go back to this guy and say, all right. So now you can connect it. Now, as you can see, the Palo Alto is absolutely creating a connection between the remote host on behalf of the client. So the client will never basically directly communicate, okay, with the remote machines or the remote network without Palo Alto encrypting and decrypting. And this is basically we are stopping the cyber criminals having out there, piggybacking our users and stealing our data. Alright, so the Palo Alto is absolutely creating a certificate on the fly, and no matter what is coming from inside and going outside, it's the man in the middle that basically negotiating what we told it to do. So how do we do that? How do we do this? So we basically tell the tell the Palo Alto, now this is a certificate that you're gonna basically negotiate with anybody on behalf of our inside PCs. Okay, so device certificate, CD-ROM, you don't forget that, do you? CD-ROM, okay? So define certificate, and we're gonna generate, all right, generate one. So here we have certificate name, and we're gonna put SSL Forward Proxy. You know what? I hate using SSL Forward because nowadays no one is using SSL. Everything is about TLS handshake. TLS handshake, not TCP handshake though, yeah? Alright, this is not basically TCP UDP transport. Alright, this is TLS transport. So shall I say this one? TLS? You know, forward proxy. I mean, the name might sound really funny, but who uses TLS anyway? Sorry, who uses SSL anyway? Alright, so I'm gonna just basically, stick that name. Okay, common name. The common name is going to be my Palo Alto firewall. I don't have a certificate at the moment from outside. I can't basically, I'm not using anything. Next lab, I will be exporting a certificate from the file from a Windows server. But at the moment, who owns the certificate is the Palo Alto. It's the one that generates certificate. It's the one that negotiates with remote PCs or connection on behalf of our clients. Okay, so the IP address is there. You can basically put fully qualified domain name or IP address. Okay, here. Now, it's recommended that we need to use DNS or fully qualified domain name because you can change the IP address anytime. Are you going to change your DNS overnight? No, it's not. It's not practical, innit? Because you can have multiple IP addresses pointing to one DNS so that it's easy for me to have DNS rather than flying off IP addresses. Okay, I'm also going to tick this box and say, okay, what? You are the CA. You are the one basically generating this stuff. As I said, I'm going to use RSA. Also, I'm going to stick to 2048, the BIF key. SHA-2 is absolutely there already. Can you see here SHA-1? We don't want a SHA-1. Okay, certificate attributes, who you are, where you are found, and so on and so forth. What's your contact? So I'm going to say country, and I'm going to basically pick a United Kingdom. Right? Great, Brian. We are great. Okay, cool. State. We don't have a state. Let me see. We've got province here. Oops. Nah, it's American made, innit? Just joking. We don't have province. So basically, I'm just gonna stick state. What? Why there's no state here? Oh, because I've already got a state. Damn. London. Okay. The next, I'm gonna put organization. And I'm gonna say Fadila Techno. Yeah. Okay. I'm gonna put department. And I'm gonna put IT, and the name, we love it. Okay, cybersecurity. I'm gonna put email so that people can contact me. So if you love what you're watching, then you can contact me. So I have completed the boxes. Number 1, local. Certificate type, this is local. This means the certificate is stored in Palo Alto. Local. It's a locally generating certificate, alright? Or locally generated, I will say, certificate. And certificate name is basically SSL TLS Forward Proxy. Right, common name is not the fully qualified domain name, but is an IP address. Tick the box because you are the CA. And then basically cryptographic setting. Public key, private key we said, we're going to stick to RSA. Now here there's a DSA here. DSA means it's not encryption decryption. Remember that. This is just only a digital signature method. So if you want to sign something, right, you use this one. You don't use it to encrypt and decrypt a traffic. Right? That's a difference. Okay, the key, why do you flip to 512? Why do you again flip to SHA-2? So make sure when you change something, it's absolutely gonna go. It's not gonna go crazy. Now, certificate validation, I'm gonna choose this one 90 minutes. What did I say, 90 minutes? 90 days. Why? You might be decommissioning the firewall. The client might be only testing the platform. They might be only signing 3 months contract, okay? And you don't want to basically spend money and time because you set up the certificate a year. So you don't need a year, alright? So think ahead, always think outside the box. What is the certificate for? What is it for? 90 days? Okay, 3 months, 4 months, 5 months, 6 months, because you might be decommissioning the firewall. The client might be only testing. There might be only short contract. Okay, so always have the length. Okay, expiration date short. All right. So we're gonna generate this. Successful. Now we created a certificate and it's not going to do anything. We're gonna open up. We're going to say SSL. Okay, why am I saying SSL? You know, because my brain is just spitting out. Forward Trust Certificate. That is the box we need to tick it. All right. Okay. So remember C and D. If somebody's asking you, how do you create certificate in Palo Alto? Oh, my head, mate. My ears, mate. Oh, what was that, man? My feet. No. It's basically define certificate CD-ROM. If you remember CD-ROM, then you can remember everything else. Right. What's the next? The next one is object and decryption. All right. And that's going to be OP. So we're going to go to object and we're going to basically find, where is that place? We're going to find decryption profile. Okay, decryption profile is where we're gonna tell the firewall what to negotiate, which public key to use, which TLS version to use, which SHA to use, and so on and so forth, which encryption to use, so on and so forth. Now I'm gonna clone it. Okay, I'm not gonna clone a sheep. I'm not a scientist. All right, remember. Because the name was kind of like to do with those people. But I am cloning a button. Alright? That's it. No life. No blood, no bones. Okay? So, I'm going to open this. I'm going to say my cert. This is basically the stuff. Now here we've got some tick boxes to select. I'm going to select the first 3. Alright? No expired certificate, no basically untrusted issuers, no unknown status. I'm also going to select the other 2, alright? I don't want any unsupported versions. What is that? That basically, I am telling the firewall only accept a TLS 1.2, nothing below. That it is it, alright? And what's this business? What's ciphers? Cipher. So from plain text into ciphertext, what is that? No, literally what it means in plain English, I don't want to basically accept anything that I have not selected. So for example, I want to have TLS 1.2. I want to have basically AES encryption. I want to have SHA-256. All of these, when you put together, it's a sort of pizza. No, it's not pizza. No, it's basically a something what? This is what we call cipher. So the encryption, decryption, TLS version, public key, private key, all of this together, ciphers. So the ciphers we selected were what? We said, you know what, TLS 1.2, yes. SHA-256, yes. RSA, yes. AES. Alright? All of those are the ones that we want the firewall to accept as ciphers. Also, I'm gonna basically select this one. What this means is that, let's say for example, we don't have a resources for the firewall. The firewall is being absolutely hammered. Okay, we gain DDoS, we gain buffer overflow, alright, and it cannot process the certificate. We want to stop the whole traffic. Or maybe because we are doing something absolutely maintenance mode or whatever, which there's another box as well, and it's not processing anything. And somehow the firewall has some sort of it's suffering from symptoms. Food poisoning. DDoS, yeah, it's a food poisoning, alright? Buffer overflow is what the firewall may be suffering, alright? So in that situation, we're gonna say stop this, right? The next box, this box is very interesting. Now if you're working for a company that is absolutely paranoid, with security, alright, not really paranoid with security, but absolutely they are running a company that they have tick boxes, alright, and basically what I was ticking here, it's coming from another device, a USB device, or maybe a device out there. So what TLS version, what public key or private key, what SHA, all of these are coming from HSM, hardware security model. Okay, so the firewall is gonna go there and retrieve all of those configurations from there. You're not gonna put here. It's gonna go out and retrieve it. At the moment, I don't have this. I'm just running this on a lab. So keep that for yourself. No, we will later try to do this in a simulator. There are SafeNet, there are companies who out there basically, SafeNet, what they call it? Was that SafeNet? What was that name? Was it SafeNet? I forgot the name. I think it was SafeNet. Okay, so this company provides this device. So if they're gonna give you some trusted login, alright, mobility they call it. Okay, so whatever boxes I am about to tick will come straight away from here. So at the moment I don't have it here. So the next box is basically block downgrade on no resources. Here when you downgrade in the firewall from version to version, basically if the firewall is not basically able to decrypt and decrypt traffic, you just tick this box as well. Now let's move on to the next one. Here is very interesting. Here what we're telling the firewall. Okay, so now I have got SSL version 3 that died long time ago. 1.0 died as well, 1.1 died as well, 1.3, and this is the one that we basically want to negotiate, 1.3 and 1.2. Okay, so I'm saying to the Palo Alto, please start your negotiating with 1.2. If anybody out there is having 1.3, then allow it. Okay, now here also we're gonna basically take RSA and untick other two. Oh! Now there is no company out there who is only using RSA, because we know today every company has a junk of companies inside, and as a network and a security people, we're asked to support everything. We are expected to know junks And at the same time, you know how much you get. So if companies out there, please listen to me. Do you know the amount of knowledge that those poor guys have to go out and grab it and learn? It's absolutely shocking, okay? Because you are, as a employer, that you don't know what these people are facing. That's why you don't even basically dare take time to pay them well. This is why from 2014 to 17, everyone was going for contracting, because you don't pay the money. So please, if you're out there listening, even today, securities, there are people who are earning a hell of a lot of money. All right, and they tick politics boxes. Okay, and the poor guy who are implementing are getting half of the security tick box person. It's not fair, innit? It's not really fair. So basically, we're gonna keep those ones. Diffie-Hellman group with immeasurable, and Diffie-Hellman group with elliptic curve and basically immeasurable. All right, but we're gonna deselect SHA-1 and we're gonna keep SHA-2 as we said, and SHA-3. Now here we've got CPC. CPC is less secure than basically GCM, and we're gonna commit. Okay, so as you can see that, look at them, the one we clone it. So the boxes here, the boxes here are empty, the boxes here are fill up. So we have nice and neat. So let's recap. Go to devices, or go to device, and then go to certificate. Right, create the certificate and make sure you tick the box, right? And make sure this certificate has all the bits and pieces. You can see now this certificate, you know, is what? The subject, and this is all of it. You can see here, ta-da, ta-da, ta-da. This is what we have, the subject, the issuer, ta-da, 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 ta-da. And look at this. This is basically what we're expecting. Organization, blah blah blah, CN, a lot of stuff. Anyway, okay, with IP address, with who we are, state, subject, and so on and so forth. Okay, and we're gonna go to basically object, and we have created the object decryption profile. We have cloned it, we modify it, we tick the boxes here, and we also ticked the boxes here. Great, excellent. Last, we're gonna go to policy, and we're gonna create a policy basically. Now, before we create a policy, we can clone one of these, but this is all basically. So let's basically create zones first. So we're gonna go to network, and we're gonna create zones. Okay, we're gonna create inside and an outside. Okay, so this is gonna be inside, and we're gonna create another one. It's gonna be outside, and let's say this is gonna be layer 3. Oops. We're also going to modify the other guy. Tab layer 3. Now we're going to go back to policy. We're going to create. So we call it inside outside. This is SSL TLS outbound decryption. So if my friend, one of my friend or one of my colleague, one of my mate comes here, they know exactly what I meant here. Source, where we're coming from. Destination, where we're going to. Okay, TLS. We are basically decrypting all SSL TLS. Yeah. Option, decrypt. The type is SSL Forward Proxy. Okay, so here we have my cert, and we're gonna say login, whatever. Now, log profile. If I had a log profile, I would have seen here, but I don't have one now. So let me put OK, and let me commit. Okay, as you can see here, we have a message here popping up, and it's saying decryption forward decrypt and trust cert is not configured. Forward decryption trust cert will be used, okay, instead. So normally you create two certificates. One is trusted and the other one is untrusted. So let's see what that means. So in here, on the, we go CD again. So CD, remember CD, and then remember basically OP, and then remember PD. So CD, OP, and P and a D. So if we go back to there, and here we have one certificate that is trusted. Palo Alto is saying, hey, you have not created the untrusted one, so that users who are there browsing untrusted certificate will not be warned, okay? Because the Palo Alto will negotiate and will tell the user, hey, that's not trusted, watch out. All right? So that's what it's saying. So it's saying any traffic that's going out from the policy, all right, from inside to outside, I will use the trusted certificate only. I will not use untrusted certificate. Now, let's basically recap what we have done and what we've presented with the basically lab here. Now, what we've said was this. At the moment, any PC who is going out to Google, all right, will be absolutely, okay, subjected to this policy, all right? And where is that coming from? Because this profile is the one that's going to work. So the PCs will be, also the PC traffic will be intercepted by the firewall, and they will not get connected unless they have this, okay, condition. SHA-256, TLS 1.2, okay, RSA, Diffie-Hellman group, so on and so forth. Also, they will not accept, okay, expired certificate. They will not, did I say accept? They will not accept expired certificate. They will not accept untrusted issuers. They will not accept unknown certificate. Alright? They will not accept basically unsupported version, neither unsupported ciphers. Alright? And who is basically doing all of this? The firewall. Alright, so let's basically go back to the presentation and see what we said before. Okay, so what we said was that basically create encryption, decryption certificate. We did that. We went to CD. All right. We created outbound in this time, not inbound certificate. We create the certificate as a trust certificate. We create a decryption profile. We went to object and a decryption, okay, that OP. We create a certificate from the device certificate, CD, and we create a profile from PD, all right? And we attach that profile to a security rule, right? Great, excellent. We also said, we modified the certificate and we said only accept the TLS 1.2, only accept SHA-256 and AES, and also we created and accepted RSA and Diffie-Hellman group. Excellent. Now, if you liked what you've been watching, this is how I train. As a Mohammed Wasame, and this is what I basically talk about and advocate, all right? No cheap, no cheat, no chunk of 5 days courses. I slice the courses. Because remember, when we go out there, we buy a pizza and you see the pizza is in a box, all right? You don't take the whole junk in one way. They sliced for you so you can eat piece by piece, or you can also share those pieces with your siblings, with your brothers, sisters, mom and dads, and so on. Now, imagine this pizza, all right, is the junk of 5 days course. Imagine you go there, you pay 5,000, 2,000, whatever, 5 days. You can't eat all of this, mate. So what I do here, because what I've seen for the last 15 years, I don't believe that works for anybody. No one is stupid, but at the same time, no one is absolutely have the brain that they can store and recap and retain thousands of configuration within 5 days, 9 to 5. It's unbelievable. So if you're a company out there, if you want to send your use out there, speak to me. We'll spin up Skype, spin up WebEx, spin up basically Zoom, wherever that you want it. I will basically do the demo and you pay nothing, all right, until you are satisfied. If you're a student, go to my website, fadilatechno.com, and you will see pick a course. Palo Alto there now, I'm offering $5.99. All right. So I'm absolutely teaching the way you saw today. No more, no less. All right. And that is it. So if you basically want to scale up and you want to basically climb the ladders of opportunities, please join me. Until then, see you, bye.